Okay, so look at this problem. Okay, we got 50 students living in a dormitory. The parking lot has the capacity for 30 cars. Now, if each student has a car with the probability 1 over 2, and it's independently from each other, what is the probability that there won't be enough parking spaces for all the cars, right? So here I'll give a hint that is set X to be the number of the cars owned by those 50 students in the dorm. Then write down X follows which distribution. So clearly, the probability of having a car is 1 over 2. So not have a car is also 1 over 2. So you can think about it, each of them is a Bernoulli trial. And you have 50 of them, right? So the distribution for this X is gonna follow a binomial, right? So which is U50 and P equals 1 over 2. So what are we looking for? You see the range of X is going to be 0, 1, 2, up to 50, right? What we're looking for is what? We're looking for what is the probability that when the number of the cars owned by those students is greater than 30, right? Then don't you agree that we don't have enough space, right, for the parking lot? So that is what? That is K from 31 to 50. 50 chooses K, and then it's going to be 1 over 2 to the power of K times 1 over 1 minus 2 to the power of 50 minus K. So this is also 1 over 2. You combine them. So 50 chooses K. And it's just a 1 over 2 to the power of 50. So this is a very simple problem. Okay, so now we can move on to look at number 4. Okay, number 4, it said that okay, we have X is a continuous random variable. PDF is given. Okay, now if the PDF is given here, what we are looking for? Okay, we want, first of all, the PDF, you see here, X is greater than 0, C e to the power of negative 4x. We're looking for C. And then after you got that, figure out what is the CDF, right? Once you drive it to CDF, well, then things become super straightforward. And after that, you're looking for what is the probability when X is greater than 2, less than 5, right? So, okay, so let's do one by one. Now, first part, to figure out C, because PDF is given here, based on the property of the PDF, that is the integral from negative infinity to positive infinity, f of x here, dx, gonna equals 1, right? So that is the one of the properties for the PDF. But we can do it from this becomes into from 0 to infinity, c e to the power of negative 4x dx, right, equals 1. So we can evaluate these pieces. On the left hand side is going to be c times negative e to the power of negative 4x over 4, right? If you can easily to do substitution. So let, I don't know, k equals negative 4x. So, right, so it's easy to do the substitution. Or let u be negative 4 of x. So if you set u equals negative 4x, du equals negative 4 dx, right? So you can do all this, use substitution here. Now the limit is going to be still the same thing, right? Well, it's going to be from negative infinity to 0. But, anyway, you can do that part. So it turns out this is negative e to the power negative 4x over 4 from 0 to infinity. A equals 1. And it turns out that if you plug infinity, this part becomes 0. So it's going to be minus 0. So it's a c times 0 minus negative e to the power of 0 over 4, right? So equals 1. So this part, as you can see, minus become plus. So it's a c over 4 equals 1. So easily you can drive that c equals 4. That's pretty simple. Once you drop that, notice that the PDF is going to be 4 e to the power negative 4x. X is greater or equal than 0. 0 of the y's, right? 0 otherwise here. And as you can see, if we're looking for the CDF, remember, if we know the CDF for a continuous random variable, we take the derivative and then we drive its PDF. When we have the PDF here, very similar here, don't you agree? We can integrate it with the PDF, so we can drive its CDF. In fact, if you look at even closer, realizing that this actually is an exponential, right, distribution. So to figure out this CDF, let's say capital. So what are we going to do? We're going to set up the integral from negative infinity to x, 4 e to the power of negative 4. Let's use a different variable. Let's call it u, okay? And then, so easily we know that. So that's the setup. So case 1 is when x is less than 0, do you realize that the CDF equals 0? Okay? When x is greater or equal than 0, that CDF realizing that is going to become into from 0 to x, right? 0 to x here, and then 4 e to the power negative 4u du. And it's very easy. You can do these pieces. So this is going to be negative e to the power of negative 4u, right? Evaluated from 0 to x here. So it's negative e to the power negative 4x minus negative e to the power of 0. So this part, oh Lord, Jesus Christ. What I'm doing, I am very sorry that I didn't notice that when I do the recording, it didn't show. So this is what we drive. We drive the PDF already, so hopefully you see that part. And then, based on the definition of the CDF, which is the integration from negative infinity to x of the function of the PDF here, which is 4e to the power of negative 4u du. I'm using a different variable because x is already part of the limit here. Now, I discussed it if x is less than 0, so this whole piece is going to become into 0 here, right? And only when the scenario is x is greater or equal than 0, so realizing that this integral is going to be comes into from 0 to x, and 4 times e to the power negative 4u du. And the integral of this piece is going to be negative e to the power negative 4u, evaluate from 0 to x. So just plug in x minus plug in 0. Turns out this part is negative 1, and there is another negative. So give us is 1 minus e to the power negative 4x. Okay. So put everything together, the CDF, which is going to become 1 minus e to the power negative 4x when x is greater or equal than 0, and then 0 otherwise. Okay, so that's part 2. Part 3, it asks us to figure out, okay, what is the probability that x is between 2 and 5, right? So for this question, you do have 2 ways to handle it. The first one, you can set up the integral from 2 to 5, right? Just right, because the integrated with the PDF, you can drive that apart. Or we can use, the x is greater than 2, less than 5. Don't you remember that we can use the difference of the CDF to solve that part easily, which, as you can see, this is 5, this is going to be 1 minus e to the power negative 20 minus 1 minus e to the power negative 8. So it turns out this is e to the power of negative 8 minus e to the power negative 20. Okay, so yeah, so you can easily verify that this, so it's or easily you can verify this is exactly the same answer as this one. So I prefer to use the second one because you don't have to handle the integral part. So that's it. Okay. So thanks for watching, and appreciate it.